Alright, so this is our AP Chemistry lesson video for Chapter 20, and it is Part 1. And in this video, I'm going to cover Section 20.1 and 20.2. Alright, so let's get started. So today we are going to start on electrochemistry. So first, we're going to go back to something from Unit 1, which is oxidation reduction. Alright, so oxidation is loss of electrons, reduction is gain of electrons. So if you remember oil rig, oxidation is loss, reduction is gain. Electrochemistry is the study of the relationships between electricity and chemical reactions. So we're going to look at how chemical reactions can produce like a current and voltage and things like that and actually be used for electricity. So first though, we need to go back all the way to Unit 1 to redox reactions. So oxidation reduction or redox reactions, you have both oxidation and reduction. Okay, so you can't have one without the other. They have to both occur together. All right, so the substance that makes it possible for another substance to be oxidized is called the oxidizing agent. And a substance that makes it possible for another substance to be reduced is called the reducing agent. Now, they've said on the AP exam that they no longer make you identify oxidation and reducing agents, but I'm still going to cover it in this video. But you do still need to be able to tell if something is oxidized or reduced. Alright, so let's look at our first one together. So it says that we have a nickel-cadmium battery, a rechargeable dry cell used in battery-operated devices, and it uses the following redox reaction to generate electricity. So here's our reaction. So it says identify the substances that are oxidized and reduced, and indicate which is the oxidizing agent and which is the reducing agent. Alright, so again, on the AP exam, they only might ask you what's oxidized and reduced. They're not going to ask you about the agents, but we're going to go ahead and answer that part anyway. Alright, so any element by itself, of course, is 0 for its oxidation state. Oxygen is -2, but since there's 2 of them, that's -4, so nickel must be +4. Okay, remember, for a neutral substance, the oxidation states must add up to be 0. Hydrogen, when it's with a nonmetal, is +1. Oxygen's -2. All right, here we have OH, so hydrogen's +1, oxygen's -2, and that makes sense because this should add up to make the charge, which is -1 for hydroxide. Since hydroxide has 2, that's -2, so cadmium must be +2. All right, and then here again, hydroxide's -2 and +1, but it has a -1 charge, so since there's 2 of them, nickel must be +2. Okay, so first of all, let's look at who has changed states. So I can see that CD went from 0 to +2. Okay, so CD went from 0 to +2, and I can see that nickel went from +4 to +2. Okay, so nickel went from +4 to +2. So oxidation is loss of electrons. That means that it's going to become more positive. So if I look, cadmium went from 0 to +2, so it was oxidized. And then reduction is gain of electrons. So that either means it's going to become negative or less positive. Okay, so nickel became less positive, so it was reduced. So y'all, once you figure out what's oxidized and reduced, the agent is the other substance. Okay, so since I've decided that CD is oxidized, that means this right here, even though nickel is reduced, is my oxidizing agent. Okay, so this right here, because this is oxidized, this right here, the NiO2, is my oxidizing agent because that's what allowed CD to be oxidized. And then the whole reason that nickel could be reduced is because of the CD. So CD is my reducing agent. Okay, but like I said, on the AP exam, they may ask you this part of the question, but they shouldn't ask you this part of the question. Alright, so, but I'm still going to cover it just in case. You never know. They could change it on the AP exam and start asking that part again. Alright, so CD is oxidized, Ni is reduced, so CD is the reducing agent, and NiO2 is the oxidizing agent. Okay, so y'all try this one. I'll assume you've done that, and we'll look at it together. So it says identify the oxidizing and reducing agents. So since on the AP exam they're going to focus on what's oxidized and reduced, I'm actually going to just list all of it. What's oxidized, what's reduced, oxidizing and reducing agents. So first of all, let's look at these numbers. So I know hydrogen's +1 when it's with a nonmetal. Oxygen's -2. Aluminum's by itself, so it's 0. Here, oxygen's -2. Now in this case, these oxidation numbers have to add up to give -1. They have to equal the charge. So that means I have -8. So if I want -1 overall, manganese is +7. All right, hydroxide again, we have -2, +1. And in this case, there's 4 of them. So that's 4 negatives, but overall I have a charge. So that means aluminum is going to be +3. It's going to have +3, -4. That gives me -1 overall. MnO2, oxygen's -2. Since there's 2 of them, Mn is +4. Okay, so let's look at who's changed here. All right, so I can see that aluminum went from 0 to +3. So aluminum went from 0 to +3. And then I can also see that manganese went from +7 to +4. So manganese went from +7 to +4. So oxidation is loss of electrons. So of course it's going to become more positive. So that will be aluminum. Aluminum is oxidized. And then reducing or reduction is gain of electrons. So see how manganese becomes less positive? So it was reduced, just like that. All right, and so now if we're looking at agents, though, remember it's kind of like it's flip-flopped. All right, so the reason aluminum could become oxidized was because MnO4 negative. So MnO4 negative was my oxidizing agent. Like it allowed the manganese to be oxidized. And then what allowed the aluminum to be oxidized, I think I just said manganese. What allowed the manganese to be reduced was the aluminum. So aluminum is the reducing agent. Okay, so like I said, really you need to focus on not this part, being able to get this part. And whenever on the AP exam they ask you for an explanation of how you know something was oxidized or reduced, you always reference the oxidation numbers. All right, so hopefully that wasn't too bad. So let's move on. So, section 20.2. So we're already on our second section for this one. So now we're going to learn how to balance oxidation-reduction reactions. So in balancing redox reactions, we must balance the atoms and the charge. Okay, so it's not just about the atoms, it's also about the charge. Electrons are added to the reaction to help balance the charge. Half reactions show either oxidation or reduction alone. So like here's a half reaction where it's oxidation, it's loss. See, it was +2, now it's +3 plus an electron. Reduction shows when it has gained an electron. So here we have Ce and we're adding an electron to it, and that's making Ce with only a +3 charge. And then when you combine the two half reactions, that's our overall reaction. Okay, so when balancing an oxidation-reduction reaction in an acidic aqueous solution, we follow these steps. Okay, so I can point to them. I'm going to kind of like put an abbreviated version over here. Okay, so first we separate into the two half reactions. Okay, so first we're going to separate into the half reactions. All right, then we're going to balance all elements besides O and H, which is convenient because when I teach y'all to balance, we always save H and O for last. Okay, so balance elements, but not O or H. Okay, so we're going to balance everybody else. Next, we are going to balance O, but we're going to do it by adding water as needed. Okay, so balance O with water. Okay, so if I can't balance it any other way, I'll have to add some water. Then we balance H by adding H plus as needed, because of course it's an acidic solution. All right, and then balance the charge by adding electrons. And we write electrons as just E negative. Okay, and so this is what we do if it's in an acidic condition, and it'll tell you, okay? So then, we are going to multiply the half reactions by integers if necessary, so the number of electrons will cancel out. So I'm going to abbreviate that by putting cancel electrons. All right, and then last part is add the two half reactions. All right, so obviously the only way to do one of these is just jump right into it. All right, so it says complete and balance this equation by the methods of half reactions. And notice it tells me it's acidic. Okay, so the first thing I have to do is split up my half reactions. Okay, so I can see that these two clearly go together and these two clearly go together. Okay, so that's what I'm going to pull down first. All right, so I have my Cr2O7 with a -2 charge, yielding my Cr3 positive. And then I'm going to have a Cl negative yielding a Cl2. Okay, see how all I did was I first split it up into a half reaction. So I got my two half reactions. Next, balance elements that are not O or H. Okay, so here I got a Cr, I have two of them, so I'm going to put a 2 here. Here I have two Cls, so I'm going to put a 2 here. Okay, so made it through step 2. Balance O with water. Okay, so see how I have 7 O's on this side, but I don't have any over here? That's where I need to add 7 waters. Because see, now I have 7 O's and 7 O's. I don't have any O's down here, so I don't have to worry about it. All right, next, balance H by adding H+, because of course it's in an acidic solution, so there's going to be H+. I don't have any H's down here. I have 14 H's right here. So that means on this side, I need to put 14 H+, just like that. All right, so we fixed O with water, we fixed H with H+. Next, we need to balance charge with electrons. Okay, so this one's a little trickier, so let's start down here with this one. Okay, on this side, I have 2 negatives. So I got a -2 over here. On this side, this is neutral. So how do I balance it? I put 2 electrons. So see, now I have a -2 on this side also. So that's what we mean by balance out the charges. But you gotta be careful. Sometimes you'll have more than one charge. You may have coefficients. So let's look at this one. So here I have 14 positives. And here I have, well here, let me put +14. That would make more sense. And here I have -2. So on this side, I have a +12 overall. All right, on this side, I have a +6. So this side has +12, this only has +6. So that means I need to then add 6 electrons to this side. Okay, so let me start erasing some of this because otherwise that's going to get kind of hard to read. All right, so I balance my charge with electrons. The next is we need to cancel out the electrons because we're trying to add these together. Well, if you look, the electrons are on opposite sides like they're supposed to be, but right now they won't cancel. I have 6 on this side, I only have 2 on this side. So what I have to do is take this reaction and I need to multiply it by 3. So that way I can get my electrons to cancel. So 2 times 3 is 6, 1 times 3 is 3, and 2 times 3 is 6. Okay, so see how now my electrons will cancel? So I canceled out my electrons. So last step is add the half reaction. So let's see what I have left. So I have 14H+, I have Cr2O7 -2, I have 6 Cl-, I have 2 Cr +3, I have 7 H2Os, and I have 3 Cl2. Okay, so let me just double check and make sure I got all of it right on mine. Okay, and that's what I got. All right, so it's just a lot of steps to follow. That's all that's happening here. But once you know the steps, it's not that bad. Okay, so you try the next one. Okay, so again, oh, you got 2 of them. All right, so you're going to split them, and then you're going to follow your steps and then combine them again. Okay, so I'll assume that you at least tried the first one. Okay, so let's split it first. So I can see that clearly the Cu's go together and the NO3 and the NO2 go together. All right, so I'm going to have to write kind of small. I didn't leave myself a lot of room for this one. Okay, so I have a Cu. Here, let me move over too because I got to add a bunch of stuff to these. Cu yields Cu2 positive, and I can see that NO3 negative yields NO2. follow our steps. I split my half reactions, balance all elements besides H and O. Well, I got Cu, that's balanced, N's already balanced, so I'm good there. All right, balance O with water. Okay, so here I have, if necessary. Okay, so here I can actually balance these O's without adding any water because of course I can just balance like normal. But the problem is then my N's aren't going to be able to balance. So see, like if I tried to put a 3 here and a 2 here to make them both 6, then it would be impossible to balance at that point. Okay, so that's where we balance with water. Okay, so because again, let me just show you what I mean. Like if I tried to make both of them 6, see my N's won't work out. Okay, so I don't have enough O's on this side, so I add an H2O, just like that. All right, so next I need to balance my H with H+. So I have 2 H's on this side, so I add 2H+ on this side, which of course makes sense because we're in an acidic solution, so you should see some H+ floating around there. All right, next we're going to balance the charge with electrons. So here I have no charge, this side's just 0, this side's +2. So I need to add 2 electrons. So see, that cancels out the +2 and it also becomes neutral. All right, on this side I have 2 positives, or +2, and I've got -1. So over here I have a +1 overall. On this side I've got neutral. Both of these are neutral. Okay, so what I need to do is add 1 electron to this side. Okay, to try to balance out that charge. All right, so next I need to cancel out the electrons. Well, I have 2 on this side, but I only have 1 on this side. So that means I need to take this whole reaction and multiply it by 2. So that becomes 2 electrons, 4 hydrogens, didn't leave myself enough room, 2 NO3s, 2 NO2s, and 2 waters. Okay, once I do that, I can combine my reactions because now my 2 electrons cancel and I just write what I have left. So I've got a Cu, I've got 4H+ and 2 NO3-. I've got Cu, +2, 2 NO2, and 2 H2O. Okay, so again, let me just double check and make sure I didn't make any. It is easy every now and then, okay, mine's good, to make a little mistake, like when you're doing charges and things like that. All right, so if you haven't tried part B, pause it, try it, and I'll assume you've done that. So let's look at it together. So first step, write my 2 half reactions. So I can clearly see that the NN goes with the NN, and the BI is going to go with the BI. All right, so I'm going to split it up. So I have NN +2 yields NNO4 negative. All right, for my other half reaction, I have Na BiO3 yields Bi3 positive, just like that. All right, so next, oh, hang on, I think I have an error here. Where is my other Na? I think I'm supposed to have an Na on this side. That's okay, I'll add it in just a second. Okay, so first thing is, oh, well, I can balance. When I'm balancing, I'll add my Na. What am I doing? All right, so I've split it up, so now I'm going to balance all my elements that are not O or H. Okay, so I have Mn, so I'm good there. I have Na on this side, but I don't on this side, so that's where I would add my Na. All right, I have Bi, so I'm good there. All right, so next thing I'm going to do is I'm going to balance my O with waters. Okay, so I have 4 O's on this side, so that means I need 4 waters on this side. I have 3 O's on this side, so that means I need 3 waters on this side. So I fixed all my O's. Next, I balance hydrogens with H+. So here I have 8 hydrogens, so on the opposite side I put 8H+. Here I have 6 hydrogens, so on the opposite side I put 6H+. All right, next step is I balance charge with electrons. Okay, so here's neutral, here's +2, so this whole side's +2. Here's a -1 and a +8. So this side over here overall is +7. Okay, so I got +2 and +7, so that means I need 5 electrons on this side. Okay, so then I just look at my bottom one. So I have 6 positive right here. This is neutral, so I've got +6 on this side. I've got a +3, I've got a +1, and I've got neutral. So on this side I only have +4. Okay, so what that means is I need 2 electrons on this side like that to cancel out. Okay, so let me erase all this extra stuff that I've been writing. All right, so we look at this one. So next step is, of course, cancel my electrons. Well, I have 5 electrons and 2 electrons. So what's the common factor? 10. So I'm going to take my top reaction and multiply it by 2. I'm going to take my bottom reaction and multiply it by 5. So this becomes 8, 2, 2, 16, and 10. This becomes 10. What am I multiplying by 5? 30, 5, 5, 5, 15. Okay, and so now I'm just ready to add them all up. Okay, so this time I'm actually going to have more than just electrons that cancel out, because remember, anything on opposite sides will cancel. So I can see my electrons cancel, but if you look, I have 16 hydrogens on this side and 30 hydrogens on this side. That means 16 of them are going to cancel, and I'm going to be left with 14. Okay, so all I do is just cancel. Like, think about like Hess's law and things like that. All right, so next, let's see, I got some waters that can cancel, because I have 8 waters on this side and 15. So 8 of them will cancel, and I'm left with 7. And then that looks like that's all that can cancel. So then I just write what I have left. So I have 2 Mn plus 2. I have 14 H plus. I have 5 NaDiO3. All right, and then what I'm yielding is 2 MnO4 negative plus 5 Bi positive 3 plus 5 Na positive plus 7 H2O. And so real quick, y'all, let me just double check. Again, there's a lot going on these, so I don't want to put any errors up here. Okay, and mine's all good. All right, so just be aware that this part almost threw me off, is that sometimes you do, like to balance another element besides H or O, you might just have to add that ion in there. Okay, so just be aware of that. Sometimes that happens. All right, so now let's look at, well, what happens if it's in a basic solution? So I know you're probably like, oh my gosh, a bunch of different steps. It's not, it's just one extra step. All right, all the rest of the steps are the same. So what happens when we balance in basic? Well, when balancing oxidation reduction reactions in basic, you start the way we did in acidic. After you balance the H plus and the electrons, then you add the same number of OH minus as H plus on both sides of the reaction. Because the thing is, an OH minus and an H plus are going to make water. They're going to cancel out and make water. The side of the reaction that has both H plus and OH will form water. Okay, so once I balance the H plus and the electrons, then that's when I add OH to both sides to cancel H plus. So I know you're probably like, how could this get any longer? Well, putting it in an a base instead of an acid. So this happens under basic. And of course it makes sense because acids would have H plus, bases would have OH minus. All right, so let's look at the first one together. It says complete and balance this equation is taking place in basic. So I'm still going to start by splitting it so I can see that the Cn and the CnO go together and then the manganese ones go together. So I split that up. So Cn minus equals CnO minus. All right, and then my MnO4 minus equals my MnO2. All right, so yeah, I just keep working. So I balance all elements that are not O or H. So C, C, N, N, M, N, M, N. Well, that was easy. All right, I balance O with water. Okay, so here I have an O, so I put a water over here. Here I have 4 O's and 2 O's. Now again, I know you're probably like, oh, well let me just put a 2 here. Well then your NNs won't balance. Okay, so you have to add 2 H2O's. All right, so now I have 4 O's on this side. So then we balance the hydrogens with H plus. Okay, so I come over here, I have 2 hydrogens on this side, so I need 2 H plus on this side. I have 4 hydrogens on this side, so I need 4 H plus on this side. And then next we do our charge. So we got to do those electrons. All right, so this is neutral, this is -1, so this side's -1. This is -1, but this is +2. So I've got a +1 on this side. So that means I need 2 electrons on this one. 2 electrons. Alright, so then I'll look at my bottom one. So here I have 4 positives and a negative. So on this side I've got positive 3. Here I have neutral and neutral, so I have 0. So what I would need over here is 3 electrons. Just like that. Alright, let me just make sure I'm not making any errors as I go. Alright, that's what I got on my paper. Alright, so I've got to fix my electrons real quick. Okay, so the problem is I have 2 and I have 3. That means this one I need to multiply by 3 to make 6. This one I need to multiply by 2 to make 6. So this becomes 3. Oh, my plus was too close. 3. 3, 6, 6, just like that. This becomes 6, 8, 2, 2, and 4. Okay, and so see, now my electrons will cancel. But before I can add up, that would have been for acidic. Now we've got to cancel out those H pluses. Okay, so here, let me get rid of all this just so I got room to write. Okay, so remember, we cancel out the H pluses by adding the correct amount of OH minus to both sides. Alright, so what will cancel out 6 H pluses? 6 OH minus. So I'll put 6 OH minus on both sides, but the thing you have to remember is these are going to make 6 waters. Okay, you've got to keep that in mind. So instead of having 6 H plus and 6 OH minus now, on this side I'm going to have 6 waters. Alright, so then I go down here. Okay, so I have 8 H pluses on this side, so that means I'm going to put 8 OH minuses on both sides. But these are going to cancel out and become 8 waters. Okay, so now I did that part, so now I just need to cancel everything. Okay, I already canceled my electrons, so let's see what else cancels. Okay, I can see that I have 6 waters here and 8 waters over there, so I can cancel 6 of them. So this is just going to be 2. Alright, I've got 8 OHs here and 6 OHs here, so I can cancel 6 of them. So that's going to be 2. And then, oh, I still have more water. I didn't even count those yet. Alright, I have 4 waters here, and I still have 3, 4, 5 over here. So I can cancel 4 of them. So that gets rid of all of those, and I'll just be left with 1 water. Okay, and then, oh man, this is a lot to look at. I'll definitely have to check my answer when I'm done with this one. Alright, so that's gone. 1 water. So I got a water. I've got, oh wait, sorry, that's all gone. I got 1 water from here. I got 3 Cn minus. I got 2 MnO4 minus. Alright, and then I'm making 3 CnO minus plus 2 MnO2. And then that's canceled, 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 and 2 OH minus. Okay, because I still had 2 of those. So like I said, y'all, but definitely let me double check this. Okay, yeah, it all came out right. Okay, so like I said, the only part that you add to the base is when you're ready to get rid of those H pluses, you just add an OH minus to each side for them. And then remember, the side that has the H plus and the OH minus, you then would cancel those into water. Alright, so you try these 2. Okay, so pause it. I'll assume you've tried it. Oh gosh, there's not a lot of room, so I will do the best I can. Alright, so I'm going to assume you've tried it, and let's look at it together. So I can see that NO2 and NH3 are going to go together. Okay, so I'm going to have to write kind of small again. So NO2 minus yields NH3, and then I have Al yields AlOH4 minus. Okay, so first thing I broke it up. Next I'm going to balance everything besides H and O. So I have N, Al, Al. So those are good. I balance the O's with water. So I have 2 O's on this side. So I'll put 2 waters here. Alright, here I have 4 O's. So I'll put 4 waters on this side. Alright, next I'm going to balance my H's with hydrogens. Okay, so I have 3 plus 4, which is 7 H's on this side. So I need 7H plus over here. Alright, here I have 4 H's, but on this side I have 8 H's. So I'm going to need 4 H's on this side. those electrons. Okay, so here I have positive 7 and negative 1 for a total of positive 6. Here I have 0 and 0 for a total of neutral. So what do I need? I need to add 6 electrons to this side to cancel out that positive 6. Alright, down here I have neutral and I have neutral, so this side's 0. Here I have negative 1 and 4 positives, so I have positive 3 overall. So this would need 3 electrons. So if I want to be able to cancel out my electrons, I've got to multiply this bottom reaction, because see, this one has 6, this one only has 3. So I multiply this reaction by 2. So let me go ahead and do that. So this becomes 8, 2, 2, 8, and 6. So see, now I can cancel out those electrons. So get rid of those things. But now I got to figure out these H pluses. Okay, so remember, add OH to both sides to cancel out H plus. So see, here I have 7 H pluses, so I'm going to add 7 OH minus, but these are going to cancel and make 7 H2Os. But I also add 7 OHs to this side. Don't forget the other side. Alright, here I have 8 H pluses, so I'm going to add 8 OH minuses to both sides. But of course, this H plus and this OH minus, they're going to cancel, and they're going to make 8 H2O. Alright, so last step, I need to add this thing up. Alright, so let me figure out what's going to cancel first. Because in the basic one, you have a lot more that cancels if you haven't noticed. Alright, so I can see on this side, let me go ahead and combine my waters this time. I have 15 waters on this side. On this side, I have 10 waters. So that means 10 of the waters are going to cancel. So I'll have no water left on this side. And then 10 are going to cancel on this side, so I'm going to have 5 left because I did have 15. Alright, and then another thing that usually will cancel is some of your OHs. So if you look, I have 7 OHs here, but here I have 8 OHs. So I can cancel 7 of them, but I'll be left with 1. Alright, and then that should be everything that cancels, so let's write down what we have left. So we have an OH negative, we have 5 H2O, we have NO2 minus, 2 aluminums, and that yields NH3 and 2 AlOH4 minus, and that's it. Everything else canceled. Okay, so let me just double check mine real quick just to make sure. Yep, mine's all good. Alright, so if you haven't tried the bottom one, pause it, try this one, and I'll assume you've done that now, and we'll look at it together. I'm going to switch out markers real quick because this one's not that good. Alright, so I can see that my CR ones go together, and my CL ones go together. Okay, so first we start by splitting it up. Alright, so my CrOH3 yields my CrO4 negative 2. And then I have my ClO negative yields Cl2. Alright, so next step is I balance elements that are not O or H. So Cr and Cr is good, Cl and Cl2. So I need a 2 right there. Alright, next I balance O with water. Okay, so here I have 3 O's, here I have 4 O's. So I just need 1 water on this side. Alright, here I have 2 O's, here I have 0. So I'm going to need 2 waters on this side. Okay, next we balance H with H plus. Okay, so I can see I have 2 and 3. So I have 5 hydrogens on this side. So I need 5 H plus on this side. Alright, down here I can see I have 4 hydrogens. So I need 4 H plus on this side. Okay, next step is balance my charge with electrons. Okay, so I have neutral, neutral, so this whole side's 0. I got negative 2 and I've got positive 5. So I've got positive 3 on this side. So I need 3 electrons on this side. Okay, so that way this side's neutral like the other. Here I have 4 positives and 2 negatives for a total of positive 2. And here I have neutral. So what that means is I need 2 electrons on this side. So as with all balancing, when you have a 2 and a 3, you make them both 6. So I took this one and I multiplied it by 2. I took this one and multiplied it by 3. Sorry, that was kind of sloppy. Alright, so this becomes 2 and 2 and 2 and 10 and 6. Alright, I'm I'm going to erase this part though because we're going to have to add those OHs. All right, and when I multiply this one by 3, this becomes 6, and 12, and 4, and 3, and 6. All right, so see, now my electrons cancel, so my electrons are gone. But now I have to fix that H plus because this is in basic. Okay, so remember, I add the same amount of OH minus on both sides to cancel out my H plus. So here I got 10 H plus. So I'm going to add 10 OH minus. Ooh, this is 10 OH minus. Looks like 100. 10 OH minus. All right, but I also add 10 OH minus over here. But of course, this and this are going to cancel and make 10 water. All right, and so then down here I have 12 H plus. So I'm going to add 12 OH minus to this side plus 12 OH minus to this side. But of course, these are going to cancel to make 12 water. All right, so last step is I just add these together. Okay, so again, there's going to be lots of canceling. Okay, so let's look at the OH minus first. So I have 10 OH minus, here I have 12, that means 10 can cancel. So all of these are gone, and this is going to be reduced down to 2. All right, waters also cancel a lot. So I have 14 waters on this side, I have 16 waters on this side. So what that means is 14 of them will cancel, and so I will be left with 2 because I had 16 on this side. And so then I just write what I have left. So that canceled, so much canceling. So I have 2 CrOH3 plus 4 ClO minus. All right, that looks like that's all that I have left on that side. And then is 2 CrO42 minus plus 3 Cl2 plus 2 H2O plus 2 OH minus. Okay, so again, let me just double check because there's lots of room for error on these. Let's see. Oh, whoops, I do have an error. This right here should have been a 6. Oh, I was multiplying it by 3, not 2. I'm sorry about that, y'all. That should be a 6. So this should be a 6. Okay, see, that's what I mean. It's so easy, like with all the multiplying and the canceling and the charges and all that kind of stuff. So now I'm good to go on mine. All right, so hopefully these aren't too bad. Like I said, once you get used to the steps, they're really not that bad. They're just a little time consuming, and then as I just showed you, since I just put a 4 instead of 6, you got to be careful and make sure you're multiplying by the correct numbers and canceling out everything correctly. All right, so that is our lesson video for today. So hopefully you didn't find any of this stuff too confusing, but just keep in mind, even though you do need to know what's oxidized and what's reduced, you should not be asked about oxidizing or reducing agents on the AP exam.